Hello students. Okay, so this is the same problem which in the part 1 I had solved using principle of conservation of energy, and I had promised that I will solve the same problem using Newton's laws of motion and kinematics. Okay, so this problem same problem now we are going to solve using second approach number 2. Just to remind you, the problem is like this. A cylinder is released from rest from the top of an inclined plane of length L, as shown in the figure. What will be its speed on its once it reaches the bottom, given that cylinder rolls without slipping? So this cylinder is rolling down and reaching to the ground. So what will be its speed? Basically, the linear speed once it reaches to the ground. So just watch the part 1 also. If you've not seen it, I'll provide the link of the part 1 in the description box and then you can see it before you see this video. Okay, so let's use the approach 2, which is Newton's laws of motion. Okay, so what do you do using Newton's laws of motion if you try to solve a problem? First thing you do is you draw a free body diagram. So, free body diagram of cylinder, right? Let's draw this. This is inclined plane making an angle theta, and this is the cylinder with some radius, let's say. Assumption, these are not given but we will assume it. Assumption, radius is r, friction coefficient equal to mu, what else, mass of cylinder equal to m. So these are the assumption. Finally, from the result, this will vanish, this will cut out finally. So now let's see, let's draw the free body diagram. So there will be a normal force on this n. There will be a weight of this cylinder vertically downward, mg. There will be friction force on this. Now tell me in which direction the friction will apply. Guess. So what is the nature of friction? Friction is it will oppose the motion, right? So assume that there is no friction in the surface. So it's a smooth surface. So if surface is smooth, what will happen? This will slide down, right? It will slide down this way. So friction will oppose the motion. So then friction will work towards upward because cylinder has a tendency to slide down. So this is friction, and we know friction is nothing but mu times normal force, right? What else? That's it. There are only three forces: weight downward, normal force, normal to the inclined surface, and friction upward. So we will just break down this weight into two components so that we can balance the equations. There will be one component of this, and there will be another component of this. If this is theta, this will become 90 minus theta. Then this will also become 90 minus theta, right? So this will become theta. This angle will become theta. So then this component will be mg cos theta. Always remember, the wherever the angle is, that component will become cos, and opposite to that, normal to that will become sine component. So this is the angle it is making. So this component will become cos theta, and this will become sine theta. Okay. Let's apply Newton's laws of motion. Which Newton's law you will apply here? This will s- uh, roll down, right? So assume linear acceleration is a angular acceleration alpha, which will be nothing but a by r. Okay, so now since this will start rolling, what will happen here? You will apply Newton's second law of motion, right? Net force will become equal to mass time acceleration for linear motion, and net torque will be equal to moment of inertia times angular acceleration. So let's apply. From Newton's second law of motion for linear motion. Net force, what is the net force here? See, mg sine theta is acting downward, down the plane, and friction F is acting upward the plane. And finally, this is moving down. It means this mg sine theta is greater than frictional force. That's why it is moving down, right? So I'll assume this direction as plus. So it will become mg sine theta minus F, which is nothing but mu n, right? And n is nothing c but mg cos theta, right? N working upward, normal to the plane, mg cos theta down to the opposite to the normal, right? So n is equal to mg cos theta. So just put the value of n here, it will become mu times mg cos theta. So this is your frictional force. So net force is mg sin theta minus F. F is mu mg cos theta is equal to mass times acceleration. Let us say this is equation number 1. For rotational motion, now let's see rotational motion. What is rotational motion? Total torque is equal to moment of inertia about this cylinder passing through the center. Moment of inertia of the cylinder passing through the center times angular acceleration. So see here, this mg sine theta, n, and then mg cos theta. All these three forces are passing through the center of the cylinder, right? So torque caused by these three forces will be zero because they are passing through the axis about which we are considering the moment of inertia. There is only one force which is frictional force which is acting tangentially, right? So this is the only force which is creating rotational motion, and this is the only force which is creating torque. Otherwise, n, mg cos theta, mg sin theta all are creating zero torque. So F times R is the radius, right? That will become your torque equal to I alpha. So this is F, we already know, a mu mg cos theta, radius R. I is what? I is moment of inertia of the cylinder passing through its center is half mr square. I hope you already know this. And alpha is nothing but A by R. Okay, this is equation 2. Let's further solve this. M and M both sides are there, so you can cross them out. This R and square will cut, and then this R and remaining R will also cut out. What is remaining then? A you can find now. A will become 2 will go this side, 2 mu g cos theta. So you got the acceleration, linear acceleration. Put this value in equation 1. Equation 1 is mg sin theta minus mu mg cos theta equal to ma. Mg sin theta minus mu mg cos theta equal to equal to ma. Ma is m times a. 2 mu g cos theta. Now solve this. So what you can find from here is you can find mu from here. So just keep mg sin theta this side and just take mu cos theta this side. So 2 and 1 3. It will become 3 mg mu cos theta. Mg and mg you can cross them out. So mu will become 1 by 3 tan theta. You got the value of mu, right? Then put this value, let's say this is equation number 3. Put mu in equation 3. So you can find out A is nothing but 2 times mu is 1 by 3 tan theta is nothing but sin theta by cos theta and then g cos theta, right? G cos theta. Cos theta, you can cross them out. This will become A equal to 2 by 3 g sin theta. You got the value of A. Now it's easy. How will you find the velocity when it reaches the ground? Apply kinematics. From kinematics we know, right? Kinematics is nothing but equation of motion. Which formula you will apply? You have A, you have initial velocity U, you want to find out velocity V, final velocity when it reaches the ground. So apply V square equal to U square plus 2AS. So final velocity V square, initial velocity is 0, 2A we found out, 2 by 3 g sin theta. And what is S? S is the distance traveled. How much distance it is traveling? It is coming from here to here. From here to here. It means its total distance traveling is L. So S is nothing but L. So what is the value of V then? This will become 4 by 3 GL sin theta. And this is what? The value of the final velocity. And if you can see in the last video, part 1, the same velocity we had got using principle of conservation of energy also. So both velocity are same, right? Because we applied two different principles, but we applied it correctly, so your result will always be correct. Okay, so I hope you learned from this video. Okay, if you like this video, if you learn from this video, like the video and then subscribe. Do not forget to press the bell icon also so that you can get the latest notification of all the new videos. Okay, bye bye.